Okay, so we're going to turn our attention to rational functions. Here's some notes you can start writing down into your summary book, give you a chance to do that. I will be flipping between screens, so just a little bit of info on each one. So you can see the format of a rational function is still a fraction in what you've got, but this instance, we've got a linear expression over a linear expression. Now, I've been a teacher for what, a bit over 20 years, maybe 20 years. Got a maths degree. And yet it was only last night when I was watching a random Eddie Wu YouTube, trying to find something that might actually be helpful for you guys rather than me creating it recording, but I couldn't, which is why I'm recording this now, that he pointed out that the word ratio is in rational, and ratio is a fraction kind of thing. You know, comparing one value to another value, and you can express that as a fraction. And I went, okay, it's only taking me most of my life to figure that out, or to find that out. That's okay. So rational, it's got to do with ratios. It's got to do with fractional stuff. In this case, our ratio is a linear function to another linear function. In the reciprocal function, it was a constant to a linear expression. Whereas, so it is a rational function as well, I should say. It's a smaller set of it. This is another rational function. As I said, other forms exist, and at the expense of obscuring what I've written here as well, I'll just quickly do it on the whiteboard, so it won't be shown up on the video. But you can have plenty of different ones. So y equals 2x minus 1 over x squared plus 1. That is also a rational function. It's just that I've got now the proportions are I'm comparing a linear function to a quadratic function, and that's the ratio. Linear to quadratic or linear to square. Or it could be x to the power of 3 plus 2x minus 1. I don't know. You can make up whatever you want to. That'd be a linear to a cubic. Or it could be 2x cubed minus 1 over x cubed. That's a cubic to cubic, etc. In this course, as far as I can tell, no, I do know. In this course, it is only a linear to linear. Okay, that's as complex as it's going to get for us. Okay, so it is analogous to the reciprocal function, really, in a way. In a very base way, the reciprocal function is linear to linear as well. The top function is just like y equals 2, and the bottom function is y equals ax plus b, something like that. You know, so it is also an equation over a linear equation over a linear equation. It's just that the top one's is a constant number, whereas this is not. It's variable as well. So here I have on Desmos a little something I prepared earlier. And this is the most simplest reciprocal function, I suppose. Y equals 1 on x. Why do I say 1? Because I've got a equals 1 here on my slider. Okay, so this is y equals 1 on x. Underneath, I've got y equals ax plus b over cx plus d. And I've chosen the most simplest values I possibly could do here as well. I've got a equals 1, b equals 1, c equals 1, d equals 2. Do you know why I didn't make d equal to 1? Yeah, well done, Lily. Straight up. Yeah, because then it would just be a flat line of y equals 1. Yeah. So I've used this phrase before. It would be trivial to have all of them equal to 1. So I've made d equal to 2 just to change up a little bit. The question I've got for you, and I'll give you 30 seconds only, really, just to talk to the person or people next to you. How do you think, when I tick on the tick, without you doing any sort of work on your own computer, without you using Desmos or your GDC, how do you think this function, so I want you to be rational about it, lol, how do you think this function is going to be different from this function? How is the rational function different from the reciprocal function? What effects do you think that this form will have on this form? Just have a little chat amongst yourselves to start with. So you might want to turn around if you want to, talk to Sam maybe. Think of the special properties of the reciprocal function and how would that change, if at all, in this form of the rational function? That's what I'm asking you to think about, really. So really quickly, Eric, give me one special feature of the reciprocal function. K over x. Okay, so diagonal symmetry. Yep. Okay, thank you. That's a much more complex one than I was thinking of. Stan, give me one more feature of a reciprocal function. You have that deer in the headlights look about you, Stan. Siggy, just one feature. Yep, asymptotes has both, doesn't it? Vertical and horizontal. Paravet, what else? Describe the shape of the graphs. Can you remember what we called them? That's a hard question. Can anyone remember? Hyperbolic. Yep, the hyperbolas. And they're self-invertible too. That's a good point as well. So think about those. Don't worry about self-invertible at the moment, but think about the picture. I'm only interested in the picture of the graph. How do you think the picture will change? When I tick that box, how will it be different? Like, I keep talking for another 30 seconds. How will it be different? How will the asymptotes be different? Will they be different? Will they still be symmetrical? Blah, blah, blah. Okay. So, do I go for a general discussion or? All right, I'd like to go for a general discussion. See what we can just pull out. Elizabeth, what did you two talk about? Yep. Well, first of all, number one, you're first of all stating that you think there will still be a horizontal asymptote. It won't be a weird one like this, just be straight horizontal one. Okay. But you think it'll shift. Oh, vertical one. So you think there'll be a vertical asymptote, but it will shift left or right. Okay. And did you have something to say about the horizontal one as well? Was it a similar sort of thing or? Yep. Okay. So I'll compress it, you reckon? Okay. Thank you. What about the shape of it? What do you think will happen to the shape of it? Sam, what did you discuss between you and Siggy? Elizabeth's given us a little bit of what she thought. You got that deer stuck in the headlights look again. I'm honestly not trying to pick on you. It's okay. I'll let you have a little brain rest. And what about the front here? Give me one other thing you might have talked about that we haven't yet talked about. Yep. So similar to what Elizabeth was saying, that there'll be some sort of dilation effect. Now Elizabeth suspects that it might be a compression. Okay, well, and Zoe, because you talked about it together. And down the back there, what else? We wondered if they'll have different asymptotes. So, like the AX on top being shift over 1 unit, while CX on the bottom D will shift over 2 units. So you suspect that it might be shifted across, maybe by 1 or 2 or 3 units. But they won't be they won't have the same vertical asymptote, the 2 lines. It won't be the same as the red one. Yeah. So yeah. Gotcha. Yeah. So similar to Elizabeth and Zoe's thinking that there will be some that they will exist, but they will have shifted in some way. Fair enough. Yeah. Cool. We're going to drill down on those asymptotes in a second. If they exist, they do. Have it down the back there. Anything else you want to add to that we haven't discussed so far? Okay. Thank you. That was pretty decent. There's one thing that no one has discussed, and maybe because it's not worth discussing, and I'm not trying to lead the witness. I'm just trying to think of other properties. The other property, did we not notice that unless there was a reflection, the regions were top right quadrant 1, and bottom left, quadrant 2. The regions were always this in a reciprocal function unless there was a reflection. Do we expect it to be in the same two regions, or do we expect it to be in opposite regions, or only on one side or only on the other? What do you think will happen? Anyone brave enough to proffer an opinion? Let's go straw poll first of all. Who thinks it'll be the same? Who thinks it'll be the opposite two? Oh, you're going to do it for every single one, though. Who thinks it'll be something different? Cookie. Okay. Let's now unveil the graph. I'll leave the red one up there as well. That's the reciprocal, so you can see the differences. Ta-da! There it is. Without drawing them in, you can kind of see that there's definitely been a shift of asymptotes, but the asymptotes definitely exist. So that's a good pick. Symmetry, I would suggest, has also occurred. I'm pretty sure it is always the way. It is the way. However, I don't think anyone, apart from, no, I'm not going to count you because you sort of did this for every single one, so you don't even count. No one really picked that it would flip. Sorry, you did it for 2/3 of the options given. All right. So they flipped. And the reason why they flipped well, it's obvious when it's pointed out, I think. Let's have a look at it. Why have they flipped? Give you 30 seconds to chat to the person next to you. Try and figure it out. Why were they the way they were in the reciprocal function? Why was it top left and bottom, top right and bottom left? And therefore, why have they flipped now? Hey, you two down the back, stop arguing so much. The strong discussion there is really, dominating the room. Okay, I'm going to give you a little phrase we've used before in other units, and it might help you make sense of this as well. Who remembers what a dominant term is? What was the marks on the exams again? Okay, so Hartman's there again. X, well done. The largest power of X. Okay. In your discussion, this goes forever in both directions, right? So ultimately, and it doesn't change. I mean, once it starts going off in that direction, it keeps on going in that direction. It doesn't suddenly flip back and come backwards. Same with this one as well. If it did flip and go backwards, it wouldn't be a function, right? It'd be a relation to the vertical line test. So ultimately, whatever's occurring on this side of the graph is going to keep occurring as we go that way. It's going to keep occurring as we go that way. So ultimately, whatever B and D is, it's going to be insignificant compared to what X is when we go further down the line, right? Like even if B and D is 1,000,000, at some point X will be a squintillion, and similarly if for negative. So in other words, ultimately B and D don't have much of an effect on where the graph's going. It certainly affects the translations and where the vertical asymptotes are because that's in the middle. But way out, it doesn't have much of an effect. So when we're considering what's happening, we can basically just look at the dominant terms, which is AX on the top and BX on the bottom. They are going to affect what's going on. Does that kind of make sense? Okay, so let's consider, keeping that in mind, all we need to do is consider what's happening when X is positive, what's happening when X is negative. When X is positive, we're going to have positive over positive, which is positive. When X is negative, we're going to have negative over negative, which is positive. So as the graph continues to grow, it's going to be, the y value is going to be positive, right? When is it not positive? I mean, clearly we've got a non-positive part of the graph here. Well, this is when we're towards the middle of the action where B and D start to have an effect. It pulls it. It could when AX is less than B kind of thing, or CX is less than D, it pulls it to be negative effectively, and hence we've got negative values down here. Does that make sense? So as I move D along, the bigger D is, the further out it's negative before it hits positive. And if I make D negative, yep, it's switching that way. Because ultimately, when D is negative, we're starting to have a much more of a powerful effect on the graph. Similarly, if I'll move that back to 2. Oh, by the way, that's when D equals 1, as Lily said. You just get a straight line with a hole in it. Actually, it doesn't show the hole, but there's a hole in it. Yeah. Yeah. If I make A negative, of course it will flip. Even a small value of A will make it flip. Yep, because it's a reflection then as well, right? Can you make because A is a slider for that. Yeah, A is a slider for that one as well. Okay. Can you make the brush one equal to the reciprocal one? Say that again? Using the sliders, could you make the rational one the same as the reciprocal? If I made, no, I don't think I can, because the X on top wouldn't change, is it? The X on top makes it quite different. But you'll notice that even when I was doing B to negative, it really wasn't reflecting as you'd normally expect it to, because of the effect of D. It's, to do a reflection, it would have to be negative and then a fraction. So the story is more complex than I'm making it out to be. But more or less, we've got this sense that AX plus B over CX plus D is going to be going off in different directions and will be pulled back in line by what the B and the D value is effectively. Okay, so I hope that kind of made sense to you. I'll turn off that one there because I want to talk about the asymptotes in a second. But before then, I thought I might just get you guys to quickly just put down a couple of other notes. Okay, so rational functions are symmetrical. We saw that in the picture. They do have asymptotes, but as people have pointed out, the asymptotes have changed position. There is definitely a transformative effect on it some way. Good news is I'm just going to give you the method by which you calculate them rather than having to sort of think it. I don't think you can really go step back from the function and go, oh yeah, I can see it's going to be this. Unlike a reciprocal function when it's like 2x plus 1, 2 over x plus 1, you know the vertical asymptote is going to be, or the horizontal asymptote is going to be x equals 1. It's not going to be as easy as that to just eyeball it. So you're going to have to calculate it. And as I said, hyperbolic in shape. Okay, so sketching. Number one, we look at the asymptotes. It's usually the best place to start. So there's a vertical asymptote and a horizontal asymptote. So remember, the vertical asymptote is what's happening to the denominator. What value does x need to be for the denominator to be 0? Okay, so looking at Desmos again, and I'll flick back to this, so I won't be long on Desmos. Looking back at Desmos, our denominator is cx plus d. At the moment, it's just x plus 2. Okay, so if I look at the vertical asymptote, then the value of the function is either going to approach the function, so the value of y, the value of the function is going to approach infinity or negative infinity at this point here. It's approaching this point here, okay? Because as I approach that point, I'm going to get a denominator which is either very, very big or very, very, very small. Okay, so the denominator is cx plus d. And so if I solve cx plus d for 0, I'm going to get negative d on c. Okay, I'll pop that into Air Sketch so you can sort of see it, but I just wanted you to see it visually to start with. So the vertical asymptote is negative d on c. Put this if it helps, don't if you don't want to. This bit in blue. So you take the denominator, set it equal to 0 and solve for x. Okay, negative d on c. Is that okay? So if I put this into Desmos and I create a new function and just say x equals negative d on c, you'll see that that line there is exactly what the asymptote is. Okay, I'll just leave it as a red line like that. What about the horizontal asymptote? The horizontal asymptote is what value does the function approach as x gets very, very big, approaches infinity, or very, very big but negative, so it approaches negative infinity. So positive infinity or negative infinity. So I'll just take you back to what we were saying before, okay? So as I was saying before, as x gets large, either positively large or negatively large, but if it gets, as we look at the magnitude of x, the b and the d start to be meaningless, right? So it's whatever b and d is, when you're talking about infinity, it's quite meaningless. Now I'm doing this on the board because it's just a very quick explanation. So that means that as x approaches infinity or negative infinity, the function is really just ax over cx. It approaches, if that, I shouldn't say equals, the function approaches ax over cx as x is really, really, really large. Does that kind of make sense? Okay, so if we cancel out the x's here, what are we left with? A over c. Okay, so that becomes the horizontal asymptote, it becomes the value that the function approaches. So I'll put that into my notes here and then I'll show you on Desmos. So the function is a over c. Plays no role in the asymptotes. Which kind of makes sense. Sorry, just in case my video didn't pick up what you said, Lily asked, so B doesn't play any role in the asymptotes, and the answer is that's correct. Which kind of makes sense because if I split this rational function up, I've got ax plus b over cx plus d, then that would be ax over cx plus d, and then I'd have b over cx plus d. I could split it into those two parts. And this bit here then starts to become a bit more meaningless as x gets really, really large. It becomes a fraction that approaches 0, effectively. So that kind of makes sense. Yeah. Okay. So I'll put that in now, just to prove my point. So y equals a over, c. And I'll just quickly edit that to be the same colour. There you go. Yeah, there's lots of interesting functions that exist for sure. I'll zoom out a bit. So there you go. the asymptotes are therefore created. So I think it's really important that you understand why, but ultimately it's those two things there that you need to, I think you need to understand why, but ultimately, pragmatically, what you're doing is you're going, I've got my graph, A over C, i.e. the coefficients of X, are what form the horizontal asymptote, and solving the bottom for setting it at the bottom equal to 0 and solving for X is what will give you the vertical asymptote. That's what it is in practically. X and Y intercepts the other thing you should work out. As you can see, because we've shifted the asymptotes, we're going to get an X and Y intercept. And it's important to probably find at least one other point to determine or confirm the regions and give scale. So if your asymptotes, because you can see that they can be sort of almost in any other region, in any two regions really. They're always diagonally opposite regions, so it's diagonally symmetrical. But so the X and Y intercept should give you one region, and then you should just go to the opposite, diagonally opposite region for the second one. But it's good practice to pick a point within that region as well, because it gives it scale. And also, if you pick a point in the other region and it's wrong, it doesn't give you that point, you can go, bummer, I've made a mistake somewhere. And that's really useful in an exam, isn't it? Confirming is, I know you can't do it all the time, and you can't do it to the nth degree because you never get through the exam, but where you can do simple confirmations, you can save your marks. I think it's really important to do. Okay, last thing. We are running late, but that's okay because I can stretch my times out a bit. I wanted to go through an example and I wanted you to practice doing this, but I'll get you to do some practice for homework between now and Thursday, and then I'll give you some more time on Thursday. So I'm going to go through 1E from your textbook for exercise 4E, question 1E, and we're going to sketch y equals 9x minus 2 over 6 minus 3x. We can have a bit of a sense of this. I can see there's a 9x on the top and a minus 3x on the bottom, so I'm feeling like we're probably going to get a bit of a flip, I think, of the regions, but I'll just work my way through the process. Remember, thinking about transformations and thinking about the effect just helps in the confirmation process. So let's do the information first. So 1, we'll do, what did I start? Did I start with vertical or horizontal before? Vertical. We'll do the vertical asymptote first. So we've got x equals negative d on c, as you can see. So x equals negative d on c, which is equal to 3. Oh, hang on, I flipped it around, haven't I? 6 on 3. But it's a negative. Okay, sorry, I'll be really specific then. Negative d on c. And the negative makes it positive. So the vertical asymptote is at x equals 2. Remember, we should write our asymptotes as equations, either x equals or y equals. It's not enough to say the vertical asymptote is 2. And number 2, the horizontal asymptote, which is y equals, and here it is, just to remind you, a over c. So a is 9, that's the top coefficient of x. C is negative 3. And so that's equal to negative 3 is the horizontal asymptote. Okay, now I'm not too sure how much space I'll need to do the rest of the working out, but if it were me, I would now be getting my sketch going now. I'm going to do all the working out first because, otherwise I've got working out all over the sketch. But I'll be getting my axes out, and I'll be putting a dotted line at y equals minus 3 and a dotted line at x equals 2. Okay, what else? Intercepts. X-intercept. Always. The x-intercept is what? Let y equals 0. Thank you. So we have 9x minus 2 over 6 minus 3x is equal to 0. We already know that we can multiply both sides by the denominator, so that's okay. We've got 9x minus 2 equals 0. And so we've got x is equal to 2/9. Yeah. I skipped a few steps there to hopefully make it reasonable for you. Okay, let's do the y-intercept on the other side. I'm trying to squeeze into this one slide. So the y-intercept is found when? Hello. So we've got y equals 9 multiplied by 0 minus 2 over 6 minus 3, 3 multiplied by 0. So that's going to be minus 2, 6, or negative a third. So that's a bit yucky, but still, it's legit. Okay, so that should give us an idea about where we're graphing. So I might actually do the sketch now, even though I'm a bit worried I'm going to run out of space, but we'll see how we go. So I'll draw my axes in, like so. This is the y-axis, this is the x-axis, always useful to label them. I'm going to change colour, and I'm going to put in my asymptotes. So I've got a horizontal asymptote at y equals negative 3. So that's about there, say. We've got a vertical asymptote at x equals 2. So that's going to be about there. Like so. I've got my x-intercept at x equals 2/9. So that's going to be something like there. This is going to look awful. 2/9. I've got y at intercept at minus a third. So that's going to be about the same distance, isn't it? Minus a third. So this tells me that my curve surely is going to be like this. How else could it be? And then because it's symmetrical, I know it's going to be like this. It's got to join those two dots. It can't go away from the asymptotes, so it's going to have to be like that. Does that make sense, everyone? But what if I stuffed up? So I should pick one other point in this region here to make sure that it all marries up. So what would make sense? It's got to be after x equals 2. So I could sort of pick anything really. So one other point, looking at it, I don't know. I could probably think about it cleverly by looking at common factors and common multiples, something like that, but I can't be bothered really, to be honest. I'm just going to pick x equals 3 and see what happens, yeah? It could be a smarter way of doing it, I don't know. So one other point. So at x equals 3, y equals 9 times 3 minus 2 over 6 minus 3 times 3. I'm hoping for an overall negative result, aren't I? So something below y equals negative. I'm hoping for below y equals negative 3. So I'm going to have 27 minus 2 on top, which is 25. 3 3s are 9. 6 minus 9 is negative 3. So that's kind of good, or just negative 25 on 3. So that's good. That's definitely below the horizontal asymptote. So what is that? That's 8 1/3. So at x equals 3, something like that, that would be 3 and then minus 25 over 3. Should have done it in blue probably. So that confirms that it's definitely in the right region. Does that make sense to everybody? Sorry, I didn't mean for it to be an entire lesson's worth there, but I think it was important to sort of tick off on conceptual understanding rather than just figuring it out. So between now and Thursday, and I've given you a homework assignment, but I just don't want you to lose the momentum. Thank you. It's exactly what I was looking for. So can everyone, I'm just going to give you a really simple thing to do, but maybe if you can do it Wednesday night, even better, really. Just as a bit of practice before you come back into the class. Can you do exercise 4E question 1? It looks a little bit like this. By a little bit, I mean... This is the question. So it's just finding the horizontal and vertical asymptote and the domain and range just for those 5. Is that doable between now and Thursday? Okay, cool. Thank you. That's it. Toodle pipsky, everybody.